शॉर्ट सीरीज जिसमें हमने फोर्थ यूनिट तक कवर अप किया है केमिकल काइनेटिक्स तक। अब हम स्टार्ट करने जा रहे हैं सरफेस केमिस्ट्री। सरफेस केमिस्ट्री डील्स विद phenomena that occur at the surfaces or interface. Interface or surface is represented by separating the bulk phases by a hyphen or a slash. For example, the interface between the solid and a gas may be represented by solid gas or solid gas. Due to complete miscibility, there is no interface between the gases. The bulk phases that welcome across the cross surfaces. Chemistry may be pure compounds and or solutions. The interface is normally a few molecules thick, but its area depends on the size of the particles of bulk phases. Many important phenomena noticeable amongst this being corrosion, dissolution, and crystallization occurs at the interfaces, and the subject of surface chemistry finds many applications in industry, analytical work, and daily life situations. To accomplish surface studies meticulously, and it becomes imperative to have a really clean surface under very high vacuum of the and order of 10 to the power minus 8 to 10 to the power minus 9 Pascal. It is now possible to obtain ultra clean surface of the metals. Solid materials which with such clean surfaces need to be stored in vacuum, otherwise these will be covered by molecules or of major components of air, namely oxygen and nitrogen. In this unit, you will be studying some important features of surface chemistry such as absorption, catalysis, and colloids, including emulsions and gels absorption. There are several examples which reveal that the surface of a solid has the tendency to attract and retain the molecules of phase with which it comes into contact. These molecules remain only at the surface and do not go deeper into the bulk. The accumulation of molecular species adsorption. The molecular species are substances which concentrates or accumulates at the surface. It's termed adsorbate, and the material on the surface of which the adsorption takes place is called adsorbent. Adsorption is essentially a surface phenomenon. Solids, particularly and finally divided state, have large surface area and therefore charcoal, silica gel, alumina gel, clay, colloids, metals in finally divided state, etc., act as good adsorbents. Adsorption in action. If a gas like O2, H2, CO, Cl2, NH3, or SO2 is taken in a closed vessel containing powered charcoal, it is observed that the pressure of the gas in the enclosed vessel decreases. The gas molecules concentrate at the surface of the charcoal, that is, gases are absorbed at the surface in a solution of the organic dye, say methylene blue. When animal charcoal is added and the solution is well shaken, it is observed that the filtrate turns colorless. The molecules of the dye this accumulate on the surface of charcoal, that is are absorbed. Aqueous solution of raw sugar when passed over beds of animal charcoal becomes colorless. As the coloring substances are absorbed by the charcoal, the air becomes dry in the presence of silica gel because of the water molecules get adsorbed on the surface of the gel. It is clear from the above examples that solid surfaces can hold the gas or liquid molecules or by virtue of adsorption. in the process of removing an adsorbed substance from the surface on which it is adsorbed is called desorption. Distinction between adsorption and absorption. And in adsorption, the substance is concentrated only at the surface and does not penetrate on through the surface to the bulk of the absorbent. Now, while in absorption, the substance is uniformly distributed throughout the surface, retains the color of the ink or goes deeper into the stick due to absorption. On breaking the chalk stick, it is found to be white from the inside. The distinction can be made between absorption and adsorption. Anhydrous calcium chloride, but adsorbed by silica gel. In other words, in addition and adsorption, the concentration of the adsorbate increases only at the surface of the adsorbent, while in absorption the concentration is uniform throughout the bulk of the solid. Both adsorption and absorption can take place simultaneously. Also, the term absorption is used to describe both the processes. Mechanism of adsorption. Adsorption arises due to the fact that the surface particles of the adsorbent are not in the same environment as the particles inside the bulk. Inside the adsorbent, all the forces are acting between the particles are mutually balanced, but on the surface, the particles are not surrounded by atoms or molecules of their kind on all sides, and hence they are possess unbalanced or residual attractive forces. These forces of the adsorbent are responsible for attracting the adsorbent particles on its surface. The extent of adsorption increases with the increase of surface area per unit mass of the adsorbent at at a given temperature and pressure. Another important factor featuring adsorption is the heat of adsorption. During adsorption, there is always a decrease in residual forces of the surface. That is, there is decrease in surface energy which appears as heat. Adsorption, therefore, is invariably an exothermic process. In other words, delta H of adsorption is always negative. When a gas is adsorbed, the freedom of movement of its molecules become restricted. This amounts to a decrease in the entropy of the gas after adsorption. That is, delta S is negative. Adsorption is thus accompanied by a decrease in enthalpy as well as a decrease in entropy of the system. For a process to be spontaneous, the thermodynamic requirement is that at constant temperature and pressure, delta G must be negative. That is, there is a decrease in Gibbs energy on the basis of equation delta G is equal to delta H minus T delta S. It's delta G can be negative, and if delta H is sufficiently high, negative value has minus 3 delta S is positive. Thus, in an adsorption process, this is spontaneous or a combination of these two factors makes delta G negative. As the adsorption combination of these two factors makes delta G negative as the adsorption processes proceeds, delta H becomes less and less negative. Ultimately, delta H becomes equal to delta T delta S and delta G becomes 0. At this state, equilibrium is attained, and there are mainly two types of adsorption of gases on solids. The accumulation of gas on the surface of solids occurs on account of weak van der Waals forces. The adsorption is termed as physical adsorption or physisorption when the gas molecules or atoms are held to the solid surface. Chemical adsorption is termed chemical adsorption or chemoabsorption. The chemical bonds may be covalent or ionic in nature. Chemoabsorption involves a high energy of activation and is therefore often referred to as activated adsorption. Easy to ascertain the type of adsorption. A physical adsorption at low temperature may pass into chemiabsorption as the temperature is increased. For example, hydrogen is first adsorbed or on nickel by van der Waals forces. Molecules of hydrogen then dissociate to form hydrogen van der Waals forces. Molecules of hydrogen then dissociate to form hydrogen atoms which are held, held on the surface by chemisorption. Some of the important characteristics of both types of adsorption are described below. Characteristics of physiosorption. Now, lack of specificity. Now, given surface of adsorbent does not show any preference of the particular gas as the van der Waals forces are universal. Nature of adsorbent. The amount of gas adsorbed by a solid depends on the nature of gas. In general, easily liquefiable gases, that is with the higher critical temperatures, are readily adsorbed as van der Waals forces are stronger near the critical temperatures. Thus, 1 kilogram of activated charcoal adsorbs more sulfur dioxide critical temperatures of 630 Kelvin than methane critical temperature 790 Kelvin, which is still more than 4.5 milliliter of dihydrogen critical temperature 33 Kelvin. Reversible nature. Physical adsorption of a gas by a solid is generally reversible. Thus, solid plus gas then gives gas solid plus heat. More of gas is adsorbed when pressure is increased as the volume of the gas decreases. Chatelier's principle and the gas flow can be removed by decreasing pressure. Since the adsorption process is exothermic, the physical adsorption occurs readily at low temperature and decreases with the increasing the temperature. Chatelier's principle. Surface area of adsorbent. The extent of adsorption increases with the increase of surface area of the adsorbent, thus finally divided into metals and porous substances having large of surface areas are good adsorbents. Enthalpy of adsorption. No doubt, physical adsorption is an endothermic process, but its enthalpy of adsorption is quite low, 20 to 40 kJ per mole. This is because the attraction between gas molecules and solid surface is only due to weak van der Waals forces. Characteristics of chemisorption. Higher specificity. Chemisorption is highly specific and it will only occur if there is some possibility of chemical bonding between adsorbent and adsorbate. For example, oxygen is adsorbed on metals by virtue of oxide formation and hydrogen formation, and hydrogen is adsorbed by transition metals due to hydride formation. Irreversibility as chemisorption involves compound formation. It is usually irreversible in nature. Chemisorption is also an exothermic process, but the process is very slow at low temperature on account of high energy of activation. Like most temperature, physisorption of a gas adsorbed at low temperature may change into chemisorption at a high temperature. Usually, high pressure is also unfavorable for chemisorption. Surface area like physical adsorption. Chemisorption also increases with increase of surface area of the adsorbent. The enthalpy of adsorption. Enthalpy of chemisorption is high, 82 to 40 kJ per mole, as it involves chemical bond formation. Physisorption, chemisorption. It arises because of van der Waals forces. It is not specific in nature. It is irreversible in nature. It depends on the nature of gas, more easily liquefiable gases are adsorbed readily. Enthalpy of adsorption is low, 20 to 40 kJ per mole in this case. Low temperature is favorable for adsorption. It decreases with the increase of temperature. No pre-appreciable activation energy is needed. It depends on the surface area, and it increases with an increase of surface area. It results into multi-molecular layers on adsorbent surface under high pressure. Chemisorption. It is caused by chemical bond formation. It is highly specific in nature. It is irreversible. It also depends on the nature of gas which can react gases which can react with the adsorbents show chemisorption. Enthalpy of adsorption is high, 82 to 40 kJ per mole in this case. High temperature is favorable for adsorption and increases with the increase of temperature. High activation energy is sometimes needed. It also depends on the surface area is to increases with the of surface area. It results into unimolecular layer adsorption isotherms. The variation in the amount of gas adsorbed by the adsorbent with pressure at constant temperature can be expressed by means of a curve termed as adsorption isotherm. Francois adsorption isotherm Freundlich in 1990 gave an empirical relationship between the quantity of gas adsorbed by unit mass of solid adsorbent and pressure at a particular temperature. The relationship can be expressed by the following equation: x by m is equal to kp 1 by m n is greater than 1, where x is the mass of a gas adsorbed by on mass of small m of the adsorbent at pressure p. K and n are constants which depend on the nature of the adsorbent and a gas at a particular temperature. The relationship is generally represented in the form of curve where mass of the gas adsorbed per gram of the adsorbent is plotted against pressure. These curves indicate that at the fixed pressure there is a decrease in physical adsorption with increase in temperature. These curves always seem to approach saturation at high pressure. Taking logarithm, log x by m is equal to log k plus 1 by n log p. The validity of Freundlich isotherm can be verified by plotting log x by m on y-axis ordinate and log p on the x-axis. If it comes to the straight line on the Freundlich isotherm is valid, otherwise not. The slope of the straight line gives the value of 1 by n. The intercept of the y-axis gives the value of log k. The Freundlich isotherm explains the behavior of adsorption in an approximate manner. The factor 1 by n can have values between 1 to 0. 0 to 1 factor 1 by n can have values between 0 to 1, probable range 0.1 to 0.5. Thus equation 5.2 holds good over the limited range of pressure. When 1 by n is equal to 0, x by m constant, the adsorption is independent of pressure. When 1 by n is equal to 1 dot x by m is equal to k p, that is x by m is proportional to p, and the adsorption varies directly with pressure. Both the conditions are supported by experimental results. The experimental isotherms always seem to approach saturation at high pressure. This cannot be explained by Freundlich isotherm. This for this at high pressure. Adsorption from solution phase. Applications of adsorption catalysis, homogeneous and heterogeneous catalysis, adsorption theory of heterogeneous catalysis, Adsorption of reacting molecules, formation of intermediate, and desorption of products. Shape selective catalysts by Zulites. Enzyme catalysts of in industry. Classification of colloids. Classification based on physical state of dispersed phase and dispersion medium. Classification based on nature of interaction between dispersed phase and dispersed the dispersion medium. Classification based on types of particles on the dispersed phase, multimolecular, macromolecular, and associated colloids. Preparation of colloids. Purification of colloidal solutions. Properties of colloidal solutions. Brownian movement. Positively charged soul. Negatively charged souls. Electrophoresis. Emulsions. Colloids around us. In summary, surface chemistry के summary. Adsorption is the phenomenon of attracting and retaining the molecules of a surface substance on the surface of a solid, resulting into a higher concentration on the surface than the in the bulk. The substance adsorbed is known as adsorbate, and the adsorbed is held to the adsorbent by weak van der Waals forces, and in all solids adsorb gases. The extent of adsorption of a gas on a solid depends upon the nature of a gas, nature of a solid, surface area of the solid, pressure of a gas, and temperature of a gas. The relationship between the extent of adsorption x by m and pressure of a gas at constant temperature is known as adsorption. Isotherm catalyst is a substance which enhances the rate of chemical reaction without itself getting used up in the reaction. The phenomenon using catalyst is known as catalysis. In a homogeneous catalysis, the catalyst is in the same phase as are the reactants, and in a heterogeneous catalyst, the catalyst is in a different phase from that of the reactants. Colloidal solutions are intermediate between true solutions and suspensions. The size of the colloidal particles range from 1 to 1000 nanometer. The colloidal system consists of two phases in the dispersed phase and the dispersion medium. Colloidal systems are classified in three ways depending upon the physical states of the dispersed phase, dispersion medium, and the nature of the particles of dispersed phase. The colloidal system show interesting optical, mechanical, and electrical properties. The process of some suitable electrolysis is known as coagulation. Emulsions are colloidal systems in which both the dispersed phase and dispersion medium are liquids. This can be of all oil in water type and water in oil type. The process of making emulsion is known as emulsification. To stabilize an emulsion, an emulsifying agent or emulsifier is added. Soaps and detergents are most frequently used as emulsifiers. Colloids and several applications in industry as well as in daily life. तो सरफेस केमिस्ट्री की थी समरी, तो हमने शॉर्ट में कवर किया है सरफेस केमिस्ट्री को, जो कि 12th क्लास का हमारा 5th यूनिट, 12th क्लास के NCERT का, जिसमें हमने वन शॉर्ट सीरीज में कवर अप किया है. 5th यूनिट है एडजॉर्प्शन, डिस्टिंक्शन बिटवीन एडजॉर्प्शन एंड एब्जॉर्प्शन, mechanism of adsorption, types of adsorption, physisorption and chemisorption, adsorption isotherm, adsorption from solution phase, applications of adsorption. So ये कुछ मेन पॉइंट्स है जो हमने कवर अप किया है. So thank you so much for watching. Please like, share and subscribe.